Our next type of free response question has Riemann sums. These are also sometimes called table problems because they a lot of times give you a table. And I just said that. So they often deal with tables. If they're asking you to calculate things with subintervals, that means you're doing Riemann sums. All right, so there's some giveaways that it's that type of problem. All right, so what are some important things to remember with these table problems? All right, the first thing is they give you a table of the original function, but they ask you to approximate the derivative. You do that using an average rate of change with the values closest to what you care about. All right, remember, what is a Riemann sum? It's basically just approximating an area of something by just adding up a bunch of rectangles. So just figure out the width and the height of each of those rectangles, and you're going to use the values from the table for that. And the table questions over the mean value theorem and the intermediate value theorem really come up. I told you not to abbreviate these in like the tips video. I abbreviated in here because I am lazy. All right, so here's the question. Again, this kind of seeing this table up here, 9 times out of 10, it means it's one of these table questions, Riemann sum questions. And the very first one, so first of all, read it carefully, pause the video, see if you can kind of get an idea of how you would do all of these. Maybe you can't do them all, but you can do some of them. All right, but we can see the question. The first part, they're asking us to approximate r double prime, and we've given r prime. So when you find the derivative of the table, and again, that just means we're doing an average rate of change. So part A, all right, you get 1 point for finding r prime using an average rate of change, and then it says indicates unit of measure. So you can see just getting the units right is 1 point, right? And the units for r prime were centimeters per day, and we know when we take the derivative of something, we just get another per that unit. So it's per day is the units of the second derivative. Per day. And you get a whole point just for getting the units correct. And again, you can write it as centimeters per day squared. That's fine. All right, so knowing the derivative can be approximated with an average rate of change got you 2 points already. Is there a time when r prime of t equals -6? Justify your answer. All right, so this one, we're knowing if the function itself is equal to something. So this is when the intermediate value theorem comes up. Remember, if we have kind of a lower value and an upper value, we have to hit everything in the middle. All right, the conditions for the intermediate value theorem is your function has to be continuous. So first I have to know my function is continuous. That's why this first sentence is important. If my function is twice differentiable, then its derivative exists and is differentiable. And if something's differentiable, it's continuous. So that first sentence means I can use the intermediate value theorem. And then the intermediate value theorem, I need to find the lower value and the higher value. And at 0, I get -6.1. At 3, I get -5.0. And -6 is in the middle. So by the intermediate value theorem, I have to declare the name. So you can see using the intermediate value theorem, I know there's a value in the middle. This whole question is recognizing it's an intermediate value theorem. If you have a table and they're asking you if your function given in the table has a value, that's an intermediate value theorem question. If they're asking if its derivative has a value, that's a mean value theorem question. All right, using a right Riemann sum with 4 subintervals, all right, basically just adding up rectangles. All right, so you can see you're approximating this derivative. It's the width times the height, so width of the interval times the height of the interval on the right side of the table. The width times the height, width times the height. And again, this is what I would leave as my final answer. All right, you don't have to do the multiplications on the additions. They write it in their perfect answer. But again, if you don't multiply stuff out, then you still get credit. As long as it's equivalent to the final answer, you still get credit. So you can literally just write, I think if you just wrote what I circled here, you would get both points. Oh, yeah, okay, I was reading this one right here. If you did a left Riemann sum instead of a right Riemann sum, you'd get one of the 2 points. But this earns both the first and second point. So you literally just write this, and you got both points. So we just have to remember how to do Riemann sums, just adding up a bunch of rectangles. This is another related rates problem. They're giving you the height of the cone is decreasing at a certain amount, the radius is a certain amount, height is a certain amount. They even give you the thing, so you just have to make sure you take the derivative of this correctly using the product rule. All right, so you get 1 for the product rule. Why does it say chain rule? I'm guessing the chain rule is the dh dt and dr dt parts. Yeah, okay. So taking the derivative correctly basically gets you 2 points. Plugging in all the numbers that you have given to you up here will get you the second point. All right, this is, again, one of those harder questions. Part D's generally harder because there's like a whole paragraph you have to read through. But they're giving you a volume. We've done a question exactly like this on a test related to related rates. It's remembering to take your derivatives correctly using all of our rules. All right, so those are the table problems. Again, we're not going to cover everything in this video, just kind of see some things. Like the Riemann sums are definitely going to be on there, so you have to remember how to do Riemann sums. We have to remember how the intermediate value theorem and mean value theorem are used. Those are definitely going to be on these table problems. But as we do practice, we'll see the things that keep coming up over and over again.